Hello, this is Jessica, and today we're going to talk about 6.7 and 6.9 equations with percents and percent applications, so very applicable problems here. Okay, let's get started. So the first thing we need to do is we're going to make these easy to solve, but we have to first know a few key ideas. So whenever it's asking what amount, number, or percent, we're going to represent that with an X, or maybe we want to represent percent with P. Of is going to mean that we are multiplying, okay? So multiplication, that's what of stands for in math grammar, and is means equals, okay? Other things that we need to think about are whenever we are multiplying or dividing by a percent, we need it in decimal form. So for example, 49% is 0.49 as a decimal. I believe you guys have been working with this in previous lessons. And if we're looking for what percent, we will need to convert this percent for our end result by multiplying by 100, which is the same thing as moving the decimal to the right 2 places. Okay, that's what happens essentially when we multiply by 100. It moves our decimal to the right 2 places, okay? So, for example, if we have x is equal to 0.34, and that's an end result for us, but it's asking us what percent, then as a percent, 0.34 would be 34%. Okay, so let's go on to some examples. Our first one that we're going to look at is number 1. 35 is 75% of what number? Okay, 35, that's staying the same, right? What about is? What did we say in the first part of this video? We said is going to be equals, okay? And 75%, remember we're going to be doing some math with that, so if I'm doing 75%, I want to use 0.75, okay? Of means multiply. And what number? So I'm just going to use x, okay? So now we have an algebraic expression that we can work with, an equation, so that we can solve for x and find out what number that is. So I'm going to divide both sides by 0.75 so that I am able to solve. Okay, so the 0.75 divides out to be 1, and we're going to be able to solve for x. And if you solve 35 divided by 0.75, you should get approximately 46.67, okay? So if it doesn't come out and it has repeating decimals or non-terminating decimals, you'll probably have some rules on your homework on a quiz or a test that tells you where to round, okay? In this case, x is equal to 46.67. Okay? Moving on to number 2, 19% of 46 is what number? Once again, let's make that percent into 0.19. Okay, so all I did there was, if it's a percent, we can make it into a decimal by dividing by 100, okay, which is moving our decimal to the left 2 places. So 19 of is going to tell us to multiply, remember? And 46 is, we said that translates to equals, and then what number, okay? So this one we actually don't even have to do any algebra, we just need to compute what is 0.19 times 46, and you have on your sheet here, it says write your answer as a whole number or a decimal, and we come to find out that when we do that multiplication, we get 8.74 is equal to x, okay? All right. Let's go on. Right now we're moving on to number 5. Here in a moment you're going to have a chance to practice some of these. Okay, so looking at number 5, it's a little bit different. This is what we talked about in the beginning. Whenever it says what percent, we're going to have to give our final answer as a percent. So what percent, we said normally we put in a variable. I'm going to put in a p, so I know that my final answer needs to be in a percent, so I don't forget by the time I'm done solving. So what percent, I'm putting in the variable p. Of, again, means multiply. 70 is tells me that that is equals and 175. Okay, so we get another algebra problem here where we can divide by 70 on both sides. What we do to one side, we have to do to the other. That divides out. 70 divided by 70 is 1, so we end up with the single p, which is what our end goal is, solving for p, what percent. And 175 divided by 70 is going to give us 2.5. Okay, but remember it said what percent, okay? So what percent means I need to multiply by 100. So 2.5 times 100. I said that's the same as moving our decimal to the right 2 places, and that is going to be 250%. So whenever you're figuring these out, we always in math want to use our reasoning skills and say, does this make sense? Okay, so I said what percent of 70 is 175? Okay, another way of saying that is 175 is what percent of 70? Well, 175 is larger than 70, okay, about 2.5 times larger. So it should make sense to you that our final answer is 250%, okay, because 175 is larger than 70. Okay, so for right now, I want you guys to take a look at numbers 3, 4, and 6. You can pause this video, check with a neighbor if you have questions. You can also ask your instructor or someone in your lab group, or if you're in the lab, you can ask an instructor or a tutor. Okay, so go ahead and take a minute, pause, and I will give you the answers to those. Okay, working on numbers 3, 4, and 6. For number 3, you should have had the answer x is equal to 2.34. Number 4, 15% of what number is 30? That means that x is 200. Okay, so moving on to 6, your answer should have been 75%. Okay, be sure to ask someone if you did not get those answers so we can clarify for you. We're going to move on to some application problems. Okay, the first one is we're going to be looking at percent increase and decrease, and the equation for that is that we're looking at the amount of change divided by the original and then multiplied by 100, right, because we're getting a percent. Okay, so the first one is find the amount of decrease and the percent decrease. Whenever I'm looking at this, you can think of the amount of decrease is the change. Okay, so the amount of decrease or the amount of increase in another problem, if you have one that's increasing, that's your amount of change. That's how your numbers are changing. So if I look at 275 and 125, where 275 was my original and the new amount is 125, then my change is their difference. So 275 minus 125, the change between the two of those is going to come out to be 150. Okay, so we have one part that we need in our equation. We also need to know what the original amount was. Well, the original amount is right here, 275. So that was given. And now we are ready to rock and roll with our equation. Okay, so what was my amount of change? Looking at our equation at the top, it was 150. We defined it as 150. And then the original amount was 275. We are going to have to multiply that by 100. That comes out to be 0.54 times 100. Okay, 0.54 repeating actually, right? So that would be 0.5454. Okay, and whenever we multiply that by 100, we're moving our decimal to the right twice. Okay, so we get 54.54%. Okay, and if we're rounding to the nearest percent, which we typically are, then that would round up. If we look next door, we have a 5 or higher, we go one more. So we're going to have an increase of, or excuse me, decrease of 55%. Okay, all right. Let's go on to example 7. All right, example 7, we're looking at buying a bicycle. So a road bike is on sale for 25% off, which would be awesome if you're into cycling. And find the discount and sale price. So the original price is $1,100 and we have a discount, we're saving 25%. So our first step is we need to find what is our discount. And you can see in the chart there that we're trying to find the discount. So the discount is 25% of or off, okay, $1,100. So we know how to find what that is from some of our first problems that we did. We said whenever we're working with percents, we're going to change them into a decimal for our multiplication. So 0.25 of means multiply times 1,100. Okay, and we get that that is equal to 275. So that is $275 is our discount. Okay, and so if we're finding our sale price, then think about this. Our sale price, if we're saving $275, then that is coming off of our original price. So we're taking it away from our original price, same thing as subtracting. So 1,100 minus 275, that's going to give us a sale price of $825. Oops, technical difficulties here. All right, so our sale price then is $825, which would be a deal. Okay, another way to think about this, if you want to, if this is confusing, then that's okay. You can just do it just like we did, but if the original price is $1,100 and it's at a discount of 25%, then that means we're only paying 75% of, so multiply the original. And if you want to check, if you take 75 times, or 0.75, which is 75%, times the original 1,100, you will also arrive at 825. In this case, and on some of your homework and quiz or test questions, they want you to find the discount anyway, so you can go ahead and do it the first way that we did. But otherwise, if you're out shopping and you want to know, you can always think, well, how much am I paying if it's this much off? Okay? So on examples 8 and 9, go ahead and pause and take a moment to see if you can figure those out. So looking at example 8, that's like our first increase and decrease problem that we did. And example 9, Allison's making 25% commission on every item sold, and she sells a $119 bracelet. So on example 9, write this down and this will help you figure it out. If she's making 25% on a $119 sale, that is 25% of the $119 that she is making in commission, right? So think about how you could solve that if it's 25% of her sale of $119. Okay, so you guys have had a chance to work on examples 8 and 9. In example 8, Jessica's rent is increasing. I sure hope not. And so your answer for that one should have been it increased by 11%. The percent increase was 11%. And Allison, in example 9, has made $29.75 on her sale. Okay, so go out there and finish your homework, and good luck.